Hello. So, this is kind of meant to be a marathon, or at least if I don't fall asleep, of me just doing maths, specifically the Trinity specimen written test, the one they give to very smart kids just before the Trinity Cambridge College interview for maths. Um, J.H. Hardy, who went to Trinity, funny enough, is famously has famously said that for a mathematician, the limit for creative work is 4 hours of maths. I am well past that 4 hours of doing maths because it's what almost nine o'clock in the night and in the evening, sorry, and I came back from school around 7 and I am exhausted. And on top of that, I am a completely mediocre mathematician. But what I'm good at is pretending to be a good mathematician. And just for some background, my name is Mahadi, and I have applied. I'm in year 13, so I am meant to apply to universities. And I applied to Oxford, St Andrews, Warwick, Durham, Bristol for maths and philosophy because I'm a bit odd. Um, and I am waiting for my maths interview at Oxford. Hopefully, I get one. I did sit the MAT and the TMUA, so I am not completely rubbish at maths. Well, I don't know what I got in my MAT, so yeah. But this is kind of me talking to myself is good for interview prep, and also just me doing maths for shits and giggles until exhaustion. I think it's good. It's a good way to build stamina. I'll just make myself very small, and I hope this is gonna keep on recording, because if it stops recording midway, I will get pissed off. Um, this is the whole thing. It's 2 pages. I've seen and done like only 2 questions. Um, it says there are 10 questions below which are on various areas of mathematics. They are of varying levels of difficulty. Some may be easy and others could be hard. You're not expected to answer all of them or necessarily to give complete answers to questions. You should just attempt those that appeal to you, and they will be used as a basis for discussion in the interview that follows. You should bring what you have written with you to the interview. So the way I'm going to do this is actually do the questions I think I can do first, and then do the questions that look exceedingly complicated down the line. I will be even more tired, so perhaps it's not the best strategy. But also, if I mean, this is probably not meant to take more than an hour, so I'm gonna give myself an hour of time, and after that, um, I will probably allow myself to use Desmos. I don't think they might help. Any questions in which you can use Desmos to help yourself out is automatically an easy question. So perhaps that might not be the best cheat. And also, I don't think Trinity College has published a solution with this, so I'm kind of on my own with this. I will do the questions I attempted beforehand first, which I have no clue they're correct. But luckily, like if you see this question, they are show that questions. So if you get this, you get this, and you're right. There is no way to be wrong unless your logic is just bad. But but that's pretty much it. So I think I'm gonna get started. I am on my iPad and I have a broken pen, so it's gonna be a bit hard writing, but I hope it works. I'm gonna first check. Oh shit! Okay, that's not meant to happen. That was an accident. Okay, okay, now it works. Um, so I'm gonna do two because nice. Three looks good. I think I did something similar before. Four. Actually, this is a good instance of pi principle of inclusion. Except I might be wrong. So I'm gonna do that next. Too many words. Automatically no. Fuck that. Uh, uh, oh yeah, I just realized I have to move on the screen actually. I'm not on the iPad. But yeah, too many words. Again, too many words. Actually, this looks very nice. Combinatorics kind of question. So perhaps. Okay, too many words. I see logs. Sorry, logs. So this might be doable. Balls automatically no. Probability. Fuck that. Um, did I say? Did I read uniform rod somewhere? Oh, here. See, one thing about me is that I absolutely hate mechanics. I used to love mechanics, but I don't know what happened to me in year 12. I just, found physics and mechanics boring. But okay, now I'm gonna stop talking. I mean, I have to keep on talking because it's kind of like the whole point of me doing this is that I talk like I was as if I was in an interview. Perhaps I should not swear because I wouldn't swear in an interview. I mean, well, I can swear in an interview, just you wouldn't want if you want to get into the place. Okay, so if I go straight down to the first question I want to do, which is two, because the first one factorials, and yeah, no, I'll do that later. And also because I actually attempted to beforehand, so yeah. I suppose I should put a timer. I mean, it's 8:50, so at 9:50 I'll second guess my life decisions. But as of now, I'll just keep on going. So question two: let L1 and L2 be two lines in the plane with equations y equals to m1x plus c1 and y is equal to m2x plus c2 respectively. Suppose that they intersect at an acute angle theta. Show that tan theta is equal to the absolute value of m1 minus m2 over 1 plus m1 m2. The first observation I can immediately make is that this looks very similar to the compound angle formula for tan, but I'm not sure if it has anything to any relations to this. The first way I approached the question is cursed because what I essentially did is turned the two lines. So I have L1, which is my handwriting. Y is equal to m1x. I should make this bigger. m1x plus c1. I turn this into vector form. So R1 is equal to, now, any point on the line. So if I input x is equal to 0, I will get C1. So that's my position vector plus lambda, which is it could be any value in the real, plus its direction vector, whatever you call it in English. I don't remember. But yeah, the logic for the direction vector is that consider line. If you go one in the x direction, you are by definition going m1 up in the y direction because m1 over 1 is m1 and that's a gradient. So the definition of a gradient is change over y over change over x. And so if you're going 1 to the x direction, for every 1 unit you go in the x direction, you're going a amount gradient up in the y direction. Someone is annoyingly um, ringing on my door, so I'm going to have to pause this for a brief second. How the fuck do I do that? What? Well, I'm gonna. I believe I'm back. Sorry for that interruption. I'm just gonna go straight into the maths. Um, Again, sorry for interruption. I have to load my iPad. Okay, as I was saying, going one by definition of what a gradient is, if you go one in the x direction, you're going gradient up in the y direction. So that's kind of how I justify my direction vector being one. That's a very small one. 1 over m1. I'm just going to get rid of this. Now, the main reason I do this is because turning everything into vector form, or parametric form, however you want to call it, is a much easier way to deal with when you have things like angles to work out or distances. So this is kind of why I'm doing this. Now, I know that cos theta is equal to the dot product between my two lines. Sorry, no, that's completely incorrect. The direction vectors of my two lines, d1, d2, where this is d1 and this is d2, times, or over, sorry, the modulus of d1 times the modulus of d2. This is the dot product. The dot product is just of these two is, I'm going to do it on the side, 1 over m1, 1 over m2. I don't think I have to justify why this is true. If I have to, I will have to. In an interview, I suppose they might ask me why are you doing this? And already, this is similar to our denominator, so I knew I was going the right way. I perhaps approached the question a completely different way, but I'm quite happy that I am saying something familiar. Now, the modulus, which is just a fancy word for distance, or at least a mathematical way to talk about distances, is just 1 squared m1 squared, and d2 is, I have to remember that I have to scroll down on my computer because those watching the video may not be able to see that. And now if I put that, well, actually, because this is very clunky to write down, I'm just going to keep it as this. But another thing that I know is that sine theta is the vector product of my two direction vectors divided by the product of the direction vectors of the moduluses. Sorry. Now, this operation is interesting because the vector product gives you the vector which is perpendicular to both of your vectors. So if I have, let's say this is A, and let's say this is B, the vector product will be the vector. Well, actually, this is a very bad example. Assume you have two planes. Oh, actually, no, that was a good example. My bad. I'll go back to that. This is one vector, and this is another vector. The vector that is perpendicular to both. This is so stupid. Why am I doing this? What? I mean, you guys kind of should get the point. I can't really draw perpendicular vector. A vector is perpendicular to both direction vectors, essentially. But the annoying thing is that in two dimension, which these two lines clearly are, it's an interesting thing to talk about vectors which are perpendicular to to other vectors. So the usual way to do a vector product. So let's say you have 1, 2, 3, and let's say you have 2, 0, 0. Why not? Is kind of to write as ijk. I mean, the first way is use your calculator, and you can't go wrong with that. The second way, if you don't have a calculator, and I'm quite sure you're not supposed to have a calculator in this exam, is to find a 3D matrix or the determinant of the 3D matrix of ijk 1, 2, 3, 2, 0, 0 in this case. And this is going to be something like this. 1, 3, 2, 0. This is a Fermat's method. But I guess if you can win an IMO medal, you should also be able to find a 3D matrix, determinant of a 3D matrix. See, my English is not on point today, clearly, and I'm not going to work this out because this is just an example, and I'm digressing. But yeah, so back to the actual question. The vector product in this case, 1 over m1 times 1 over m2. So the issue here is that this is a two-dimensional, clearly. The vectors are 2 by 1, and I can't really get a 3 by 3 matrix unless what I do is that I add zeros in the places in the k column, the k component, just so it becomes a 3D matrix. And I kind of quickly realized that that's the same as finding the determinant of a 2 by 2 matrix. So this just works out to be m1 times 1 minus m2 times 1, which is just m1 and minus and m1 minus m2. And funnily enough, that's my numerator. So we know the identity that tan theta is equal to sine theta over cos theta. We know that the denominators are the same for sine theta and cos theta in this case, so they're going to cancel out. But just for a second, I'm just going to write it. So sine theta was m1 minus m2 over the product of the moduluses of the two direction vectors, divided by cos theta, which is 1 plus m1, m2 over, again, the product of the moduluses of the direction vectors. And this simplifies because, of course, you have to, the denominators cancel out. m1 minus m2 d1, sorry, no, not d1, over 1 plus m1, m2. And because we are taking the moduluses of both of them, we can just take the modulus of the entire thing. Or take the absolute value, sorry, I should not confuse that. But yes, that's kind of the way I did the second question. It was a very nice question. I think there's a much better way to do this, and the way I did this question is kind of cursed, turning two lines into vectors. But I also think this is a further mathematician, if you know, they think a lot about vectors, especially in the A-level context, this might be the first instinct, but I don't know. Okay, I'm gonna move on to the next question. Okay, this one, which is actually, I would say it's a particularly nice integral because, let me make this full screen. Can I make this full screen? Enter full screen, nice. Because if I understand this correctly, this should just be integration by parts, but twice. What I mean by twice is that so the standard integration by parts formula is as follows. V okay, uv dash d uv dash is equal to it looks like you're typing while in full screen, staying full screen. Is equal to uv minus my iPad is bugging, u dash v. So what I mean by integrating the parts twice is that whatever I get here, I will have to integrate the parts again. And that's the reason we even integrate the parts, we should at least, is because we want to reduce the x squared into some constant term, which means that we can integrate the sine squared theta very easily. And sine squared, it is class integrating sine squared is pretty much trivial. So if I am to do this correctly, I don't know why I'm rewriting this. This should be x squared. You know what? I'm gonna forget. I'm gonna ignore the bounds for a second because otherwise it's gonna be too many things to think about at the same time. X squared integral sine squared x minus, and then I integrate 2x integral of sine, and you guys can't see this, sine squared x dx. This simplifies to x squared half 1 theta minus half cos integrates to sine 2 theta. Or I don't know why I'm using theta, it should be x. I'm using theta because I am integrating this in my head. I'll justify this in a second. And this again, actually I'm gonna keep this the same way. To justify this step I just did, let me just change colors. I know by this is a fat pen. How can I thickness? There you go. I know that cos 2 theta is equal to cos squared theta minus sine squared theta, which is equal to 1 minus 2 sine squared theta. And for those who are dumb enough to understand what I did in this, from this step to this step, is I just changed cos squared theta into 1 minus sine squared theta. And then I rearranged to make sine squared the subject. And sine squared is equal to 1 minus cos 2 theta over 2. And if you integrate this, well, you can take a factor of 2 out, and you get theta minus a half sine 2 theta. So I hope that logic jump wasn't too much of a big one, too complicated. But yeah, that's instead of like actually working this whole thing out every time, I'm just gonna plug this in to save time, which I don't think, by the rate I am going, the speed I'm going right now, seems to be the least of my concerns. So x squared a half, x minus a half, sine 2x minus, you can take a factor of 2 out, x, and integral sine squared dx. Okay, now, I'm just going to focus on this part. I'm going to integrate this by parts. So this becomes x double integral of sine squared x dx minus the integral of sine triple sine squared dx. Interesting. And that's because x differentiates to 1. So we know this is x minus at least half of half of x minus half sine 2x minus integral that. And if I take the half out and integrate this out, shouldn't be too complicated, and I take the half out here, this is, my pen, x squared over 2 minus a quarter plus cos 2x. Am I right? Cos differentiates to minus sine, so I am correct. And, well, that's just the same as before, is it? Yes. If I, wait, where does that half come from? I might have an extra factor of half. Yes, I do. Oh, that would have been a terrible mistake. Okay, so x squared over 2 minus a quarter cos 2x dx, which means that this is x cubed over 4 plus x cos 2x over 8 minus, and I hope to get this correct, x cubed over 6 plus cos integrates to sine 1 over 8 sine 2x. That was long as hell. And just to simplify a tiny bit, x3 12. I have a feeling I'm doing this wrong. Okay, and I'm gonna go back to black pen. I know if I bring the first part in, which is x squared over 2. Actually, I'm gonna expand this out. X cubed for 2 minus x squared over 2 sine 2x. Is that correct? 4 plus x cubed. Oh, but there is a factor of 2 outside of it, so this is x cubed over 2 plus x over 4 cos 2x minus x cubed over 6 minus sine 2x over 8. And let's not forget our bounds, 0 and pi. Was it 0 and pi? Yes, it was 0 and pi. So if I evaluate this function at 0, all of my terms will cancel, literally. So I'm not going to bother thinking about that. But a pi cubed over 2, sine, all the sines are gone, pi cubed over 2 again, and then when it comes to the cos term, 2 pi is 1, so this is going to be pi over 4, and minus pi cubed over 6, and the sine goes away because 2 pi is 0, sine 2 pi is 0. This is pi over 3 plus pi over 4 minus pi cubed over 6, 5 pi over cubed over 6 plus pi over 4, which is 20 pi over cubed plus 6 pi over 12, which is 10 pi cubed over 3 pi over 6, and I'm definitely wrong because I don't remember this answer being correct. So where did I go wrong? Let me change color of pen. So where did I go wrong? It is by parts twice, I know that. Okay, this is definitely correct. Is it correct? Because cos to theta, or minus cos to theta, integrates to minus cos 2 theta should integrate to minus sine 2 theta, which I did. Okay, that's fine. I don't know why I am thinking too hard about that. The next part, this one seems to be slightly more complicated. This is, yeah, that's fine. This is fine. Where did I go wrong? Can't see where I went wrong. So I don't remember this being the answer. Should be smaller numbers. So right now I can't exactly pinpoint where I have gone wrong. And I do remember doing this somewhere else. But yeah, I have to stare at this really hard. It's perhaps I went wrong here. So I took the factor of half out, because why not? and this integrates to this. Minus sine 2 theta integrates to cos 2 theta. Yes, because if you differentiate cos, you get minus sine. And I agree with that. And if you differentiate this one more time, x cubed over 3. Yeah, that's correct. What? And this is just, yes, it's correct as well. Put this together. Did I copy it down wrong by any chance? No, that's fine. Did I do this wrong? Okay, so this and this. I don't remember that. Yeah, this is the boring part of this whole thing. It's just me staring at the screen until I see the problem. And whoever's smarter than me realizing how stupid I am. Where did I go wrong? Am I bugging? No, I'm correct. Did I divide? No. I don't. This is correct. Pi by 3 and pi. I remember them. Where the fuck did I go wrong? Is it? I don't remember this double integral. It might be this triple integral actually. Did I overdo it? What if I change this part? Okay, I'm gonna rewrite this. Surely the first part isn't the issue. Because if I value this between, oh, this is too big of a pen. If I value this between, the red is here, between 0 and pi, I get at 0 this goes to 0, pi squared over 2 pi, and 0, which is pi cubed over 2, which I definitely remember being there. And this should be, well, I know this integrates to, so integrating this again, oh, that's fancy, cos 2 theta 2 is just going to give me, oh no, this doesn't integrate to that, oh yeah, no it does, it's going to give me theta minus half, a quarter actually, sine 2 theta. And if I integrate that again, I get theta squared over 4 minus plus an 8 cos theta. That's because sine theta differentiates to cos, which differentiates to minus sine, which differentiates to minus cos, which differentiates to sine. So minus sine cos, that's correct. And if I were to integrate this one more time, oh, I can maybe see where I went wrong. And it might be very stupid. Not even like a big mistake. X, the integral, the double integral. So this is the first integral, second integral, third integral. So second integral, so theta squared of 4 plus 1 over 8 cos 2 theta minus the x goes to 1. So just the third integral, theta cubed 12 minus 1 over 16 sine 2 theta. And if you evaluate that between, well, actually, this is just theta. I'm doing everything theta for now. Between 0 and 2 pi. At 0, every term is literally 0. Well, this is theta, so yes. At pi, you get pi squared over 4. And cos pi happens to be minus 1, so this is minus 1/8. Oh no, it's 2 pi, so just 1. But yeah, this should be written clearly. Otherwise, stupid mistakes occur, like this one. And minus pi cubed over 12 minus 16th over 2 pi, which is 0. And I'm going to ignore that. So this is pi cubed over 4 plus pi over 8 minus pi cubed over 12, which is 3 pi cubed minus pi cubed over 12 plus pi over 8, which is pi over 6 plus pi by 8. So if I combine the two results I get from here and here, is just adding pi cubed over 2. And this is 3. Well, am I missing something? Oh, yes, this whole thing is multiplied by 2. You just need to remember that. So this is actually pi by 3 over 3 plus pi by 4 plus pi by 3 over 2. And actually, no, no, no. This is a negative 2. This is an, oh my god, such a stupid mistake. This is a negative 2. So this is negative. Oh, I see. I'm so stupid. Pi cubed over 2 minus pi cubed over 3 minus pi by 4, which is pi cubed over 6 minus pi by 4. And that is my final answer, and that is correct, I think. Oh my, this was so. I think it's not even like my maths being wrong, just me being stupid. It's when I times this by 2, which I was in my head, I was like already thinking when I took this factor of 2 out, I'm definitely gonna forget this. I'm definitely gonna forget this. I ended up not forgetting the 2. I ended up forgetting the minus, which is, oh my god, so annoying. But yeah, I mean, I ended up getting the answer anyway, so it is what it is. And I guess if I fix this to minuses, this being minuses, I should get the right answer as well here. But yeah, moving on to the next question. God, how much time did I spend on this? Okay, I'm half an hour into this. I'm definitely not when getting to stupid Trinity Cambridge College. Okay, let me move this out the way. Actually, I'm doing this question next, so perhaps not out the way. Okay, question 4. Okay, this is actually one of the questions I haven't attempted, so it is not embarrassing if I don't do as bad as the questions as the previous questions. So the logic here is to first I'm going to work out how many multiples of 2 are between 1 and 6,000. That's not 6,000, that's 600. And you can easily work this out by doing 6,000 over 2, which, if my math is not incorrect, should be 3,000. Now, if I do multiples of 3 between 1 and 6,000, that should be 6,000 over 3, which is 2,000. So there are 2,000 multiples of 3 between 1 and 6,000. And lastly, multiples of 5 between, I don't know why I'm writing this whole thing out each time. Oh, that dot really annoys me. Okay, stay in full screen. 6,000 over 5, which, if my math is not lying to me, should be 1,200. Is it? Yes, 1,200. Now, you can have overlaps. So, for instance, you can have multiples of, what am I writing? Multiples of 2 and 3. So 6,000 over 2 times 3, which is 6, which is 1,000. Or multiples, I can't spell multiples, of 2 and 5, which is 10. 6,000 over 10, which is just 600. Did I miss anyone? Yes, multiple of 3 and 5, which is 6,000 over 15, which, again, if the math is not lying to me, 30, 60, 40, 400. Yes, it should be 400. And quick way to check this is because 15, 30, 45, and 60. And yes, that's a very, very, very quick way to check this. But I don't think if I'm doing these kind of papers, I should not be checking this. But yeah, and also last one we're missing out, if it's a multiple of all 3 of those numbers, 3 and 5 and 2, is 6,000 over 2 times 3 times 5, which is 30, and that's 200. So, it's this whole entire thing is going to be, I'm going to get all the multiples of 2, 3, or 5 first. So hopefully you guys can see here. 3,000 plus 2,000 plus 1,000 minus 1,000 minus 600 minus, oh, depended, no, minus 400 plus 200. That's, if my arithmetic is not finished, should be 6,200 minus 2,000 plus 200, 4,400. Now, these are all the multiples of 2, 3, and 5, and therefore we have to use 6,000 minus 4,400, which is 0,061, 1,600. and that would be my answer, unless I misunderstood the question. And by the way, the reason I'm doing this is because if you consider, what can I do this? 3 Venn diagrams. What I'm trying to essentially work out, is this. So I need to. So let me write. Let me use different colors. Let me call this A. Let me call this B. Let me call this C. Actually, no. By the way, A, B, C. So essentially, this is called the principle of inclusion and exclusion, otherwise known as pi. You are trying to. What are you looking for? You're looking for this area, I think. So you add the entirety of A, so PA plus PB plus PC, but you will have double counted these portions here. So you minus P, B, and A minus P, B, and C, and so on, and all its variations. But also you will have accidentally removed an extra all of them together area. So you just add that back in, P, A, C. And you can, I believe, extend this to any number of Venn diagrams. But that's kind of the logic of why I did this. And I realize I've explained this extremely poorly. But the first time I actually came across these kind of questions was in a Cambridge mock interview. When I went to visit the university, they gave out interviews for free. I'm like, why not? And I actually got to the answer. I think the question I got was phrased differently. Not how many are multiples, but how many are not multiples of 2, 3, or 5. Wait, hold on. Did I get this question? Because I remember 6,000. Wait, is this where they got the questions from? Oh my god. I am okay. So if I did get this question wrong, it would be embarrassing, and I have a small feeling that I might have. So, and I can't really check. Okay, so let's move on to the next question. Wait. Let me see if there is any one that's very fast to do. No. Let me go back to the first question actually. In a tennis tournament, there are 2 end participants. In the first round of the tournament, each player plays exactly once, so there are n games. Show that the pairings for the first round can be arranged in exactly 2n minus 1 factorial over 2n minus 2 to the n minus 1 times n minus 1 factorial ways. I have to, for this question, I have to read the question 15 times because my brain thinks of completely unrelated things when I read. So in a tennis tournament, there are 2 n participants. Okay, that's fine. In the first round of the tournament, each player plays exactly once, so there are n games. Okay, yes, because to play a game, you have to play with someone else. And if there are 2n of people, everyone's going to play with someone else. Therefore, n games. Okay, that makes sense. Show that the pairings for the first round can be arranged in exactly those many ways. Pairings. Okay, so this is a combinatorics kind of question, and the reason I kind of skipped this at the beginning is because this is the first time you're seeing kind of this. So how can I think of doing this? Is there space there? There's a space there, but there is space on the left. I don't like writing on the left, but yeah, okay. I think I should track someone. Okay, let's say I have A, B, C, D. It has to be an even number of participants. So let's say E and F. Actually, let's go with 4. Let's keep things easy. Okay. So A can play with B, A can play with C, A can play with D, B can play with C, B can play with D, C can play with D. Okay, these are all the combinations. Okay, I'm too far off. Okay, that's all the combinations possible. If I am to plug in n is equal to 2, which is this case, and I put 2 times 2 minus 1 factorial over 2 to the 2 minus 1, 1, 2 minus 1 factorial, this is equal to 3 factorial over 2 minus 1, which is just 1, 1 factorial, 2 factorial, just 3. So A can be paired up with B, C, D. So yes, 3 people. Okay, so this is the beauty of working simple, is that you can practically see if your logic does make sense or not. I'm gonna go with the case that n is equal to 3, and I don't know if every time I do case by case, n equals 1, n equals to 2, n equals to 3, I immediately have the suicidal thoughts of proof by induction. And if this ends up being a proof by induction, I am generally going to kill myself. But yes, n is equal to 3. Why do I do these things by this format? Why do I choose to do these things for fun. Okay, so what was the stupid formula again? Two. I'm gonna write it down. Some 2n minus 1 factorial over 2 to the n minus 1 n minus 1 factorial. Yes. Okay. If I evaluate n equals to 3, or in this factorial function, I'm gonna name this as a function g of x. Why g? It should be f of x. Yes, f of x. So f of 3 is equal to 6 minus 1, 5 factorial, 2 to the 2, 3 minus 1, which is 2 factorial, which is just 5 over 2 cubed, and 5 factorial is 5 times 4 times 3 times 2, 2 cubed. These go away, so this is just 15. Okay, so that means every player can be paired up with 15 other players. So if I am to practically show this by in virtue of writing actual letters, A, B, C, D, E, F, and there are 5 factorial ways A can be paired up with. No. So you have A, B, 3, 4, 5. Am I stupid? What does the sentence show that the pairings for the first round can be arranged in exactly this many ways? Pairings. Well, this is me 3. So where do I see 3? This is wrong. 4 minus 1, 3 factorial, that's correct. 2 minus 1, 1, 2, that's correct. 2 minus 1 is 1. 1 factorial is 1. 2, which is 2 factorial, is just 2. This is just 3. Huh. Something is wrong. Show that the pairings for the first round. Oh, wait, hold on. N is equal to 3. Oh, that's possible. And that's possible. So n doesn't have to be even. 2n has to be even. And 2n is always even. Show that the pairings for the first round can be arranged in exactly this many ways. What does that mean? Pairings for the first round. Okay, there are n games in total. So these will be all the games. 2, 4, 2. No. Okay, so I'm not misunderstanding the question. Tennis, do you play, is it 1v1? Each player plays exactly once. Okay, I missed this key sentence. Each player plays once. So, if my iPad loads, that means that so let me cancel all this. If A plays with B and C with D, that's all that can happen. That's one setup. Or A plays with C and B with D, that's another setup. Or A plays with D and B with C, and there is no other setup, and that's 1, 2, 3. Okay, I can see what they mean. So basically, these are all the possible pair. Oh, okay, I see what the sentence means. Okay, that's me being stupid. Okay, so in this case, it's gonna be. Oh, this is gonna take much longer. Okay, so if A plays with B, that means let's say C plays with D and E with F. That's 1. And let's say A plays with C, B with D, and E with F. Or A plays with C. Is this the way you do counting? No, you don't. It's not. That's not how you enumerate. Let me do it the proper way. A with B, C with E, and D with F. A with B, C with F, and D with E. And I can move on to A with C, B with D, E with F, A with C, B with E, and D is forced to be with F. And then AC, BF, and DE. And I assume there's going to be 3 more for AD, AD, AD. And there's going to be 1 with AE. And 1 with AF. Which you guys can't see. Okay, so this in total is 15. 3, 6, 9, 12, 15. just to check. I know it's 15. Okay, so this formula clearly works, and I mean, it wouldn't. I didn't believe it didn't work. I just need to see how it works. So how would I prove this? So if there, okay, I may hire, I can maybe think of something on the spot. So consider this. How can I generalize this? What happens between the first case and the second case? Uh, so let's say you can enumerate all 2n players as P1, P2, P3, or not plus, all the way to P2 to the n. Okay. Then we can say that P1 can be paired with P2, P3, all the way to P to the to the n. If this happens, P1 and any of these, P, let's say K, which is not 1, because it can't play with itself, can't play anymore. But the way you enumerate, the way I did it here, at least with the AC way, is that you say P1 is paired with P2, then you see all the possible ways. No, I promise I'm going somewhere with this. I'm definitely failing my interviews if this is what my performance is. I mean, this now it's almost 10 p.m. Okay, that means P2 can be paired with 2n minus 1. 2n minus 1, people. Actually, no, 2n minus 2. No, 2n minus 3. Because P2 can't play with itself, can't play with P1, and it can't play with whoever P1 played with. Therefore, P3 can be paired with 2n minus, and that 2n is diabolical, 2n minus P1, whoever P1 played with, P2, and whoever P2 played with, and P3 himself, or herself, or themselves. So that's 5. Minus 5 people. I can see a pattern. And P4 can, that looks like a 9, can be paired with, cannot be paired with 2n minus P1, whoever P1 played with, P2, whoever P2 played with, P3, and whoever P3 played with. Wait, hold on, 6? 3, 5, doesn't, and P4, so P7. Okay, so we have a very standard sequence 3, 5, 7. And I bet P1 would be P1 minus 1. Yes. Okay, so I have done some progress, clearly. Okay, so if I look at the original formula, maybe there is some nice, what do you call it, simplification I can make. 2n minus 1 factorial, 2 to the n minus 1. What was it? N minus 1 factorial. Okay. N minus 1 factorial ways. Okay, this is 2n minus 1, 2n minus 2, 2n minus 3, all the way to 1 over 2 to the n minus 1, which I'm going to put aside for a second. N minus 1, n minus 2, n minus 3, all the way to 1. And I bet all of these terms are going to be in this, and it's positive, by the way. All of the numerator, at least this part of it, is going to be above here. So, yeah. And if you notice, 2n minus 1, let's say this term can be written as 2n minus 1. And let's say the next term here will be 2n minus 4, which can be written as n minus 2, 2n minus 2. So you have, how many 2's do you have? Like these 2's I can factorize out and get this, which is in the denominator, and this would cancel out. And similarly here, like this. It's every even term. So it'll be 2n. And if 2n minus 1 is an odd term, you're going to have n minus 1 even terms. And then you have n minus 1, n minus 2, so on until 1. Okay, progress. Oh my god. Because this
cancels out, and you get 2n minus 1. And I think this can't be true, because if I plug in 2, for instance, 3. If I plug in 2, I get 3. If I plug in 3, I get 6 minus 1, which is 5, which is not what we got 15 before. So maybe we are doing something. Oh, yes, yes, because you still have the 2n minus 3 and all that. So this is okay, I see. 2n minus 3. Oh, but notice, this is going to appear. 2n minus 1, 2n minus 3, next one 2n minus 5. And guess what? This is exactly all the possible pairings that each of them can get, as we've shown above here. And the PK, they say, let me generalize this, because someone in the comments of whoever's watching this might say, oh, you haven't generalized this. PK can be paired with 2n minus 2k minus 2. No, what sequence is 1, 3 plus 1? I'm thinking. No, this should be minus 1. No, this should be plus 1. Because 1, 3, 7, 1, 3, 5, 7. This is just plus 2 each time. So it's a 2 timetable. And this is minus 1. Yes. Oh no, so this is minus 1. Okay, it's fine. Okay, so we got that. So yes, I've proved this question, and I did not expect to do this right. Oh my god, I'm so happy. Perhaps I am not that stupid. Well, that was nice. Well, I think this is not exactly polished. Polished. Yes. It's okay. I did 1, 2, 3, and 4. So I am basically halfway through this thing, and how many hours? I spent 1 hour and 15 minutes. Oh my god, I'm awful at this. Okay, but to be fair, I'd probably be happy. But perhaps if I did one more, I'd probably be happy, because I probably have what, 1 hour, 1.5. Actually, let me look it up right now. Where's my phone? How much? Fuck. How much time do you have for the Trinity Cambridge Maths pre-interview test? There is no pre. What the fuck? What are they on? Apparently, attempting 8 is very exceptional within the time. But I just don't know what the time is, and I am kind of going very slowly on this. I can't see. Oh, it is 1 hour. It is 1 hour. Okay, nice. Well, I would have done around 4. I mean, if it wasn't awfully explaining, I probably done one more. But let's see. Let's see the next question. Hopefully, it's as nice as this one, the last one. I mean, I did spend like what, a lot of time understanding this last sentence, but I think the brute force mindset I had kind of helped, and also the idea of simplifying this, because you know you are kind of going to assume this is the simplest form you can get, because it is the question. But you know what? From now on, the first thing I'm gonna do is I'm gonna check if this is the simplest way I can write this. Okay, so back here, there is a pile of 129 coins on a table, all unbiased except for one which has heads on both sides. Okay, probability. Bob chooses a coin at random and tosses it 8 times. The coin comes up heads every time. Okay, what is the probability that it will come up heads the 9th time as well? I wonder what's the probability that. Okay, no, it's not something to wonder about. It's 1 over. It's half to the 8. The probability of getting heads 8 times, which is a ridiculously small number. Pile of 129 coins on a table. Okay, all unbiased, so all of them have probability half, except for one which has heads on both sides. So it's biased towards heads, so it has a 100% probability of giving heads. What is the probability that you will come up heads the 9th time as well? Okay, that's interesting, because I can think of the trivial case. So the case, before even thinking about the trivial case, let me set up the problem. So I have 129 coins. One is biased. That means I have 1 in 129 probability of picking a de-biased, actually not a de-biased coin. Now, if I'm lucky enough to pick that, then let's say you picked the biased coin, then the probability of you getting heads on 9 time is going to be p heads is going to be 100%. But actually, it's going to be 1 over 29 if you think about it, because you have to first pick the coin and then toss it. And every time you toss, if you did pick that coin, it's going to be 100% each time. Now, let's say you didn't pick the biased one, which is the more likely case. You didn't pick the biased. Oh, I'm so sorry for my handwriting, but this is the best I can do at what's the time? I can't even read the time at 22, 8, 9, at 10 in the night. Okay, so it's going to be p heads. That's p heads any n times. Is going to be 128, 129. So you pick that coin times 1 over 2. P heads 9, no, to denote to 9 times, 128 over 129 times a half to the 9. So technically, am I right in saying that the probability that you do get? So what are all the, when I think of this question, I like to think about what are all the possible outcomes, what are my favorite outcomes, and I do favorite outcomes over my the array of all my possible outcomes. So my possible outcomes are, because you have to think about this question in two stages. First is picking the coin, and second is tossing the coins. But and I don't know if you include the 1 over 8 to the 8 probability that you turn heads every time. Okay, perhaps you don't, and I think I have to go to the toilet because I need to piss. You know what? You know what? I'll save the misery of the viewer of me desperately doing maths at outrageous hours if I finish this question so I can go to the toilet. Bro, I am okay. Oh, how can I do this? It's because with this kind of questions, there are so many things you have to consider. I think they're phrased this way because the interviewer wants you to ask those questions to clarify what it means. Perhaps it's not testing ability to do maths. This is an English comprehension question. Do I include this? Does that phrasing entail that I do include this probability or not? What does it mean? These are more philosophical and English comprehension questions, I suppose. And so 129 coins. Which has heads on both sides. Bob chooses a coin at random and tosses it 8 times. The coin comes up heads every time, the 9th time as well. I think going the brute force way, which is kind of what I was doing, perhaps the best way. So the most ordinary expected case scenario is that you pick an unbiased coin, which is 128 over 129 probability. Then you toss the coin 8 times, and you get heads every time, and you get tossed another time. So 1 over 2. I can't even speak. 1 over 2 to the power of 9, plus the chance that the probability that you get the biased coin, and you get heads every time. That's what I'm thinking. Can I simplify this? Okay. I might be very, very much wrong on this. I am so tired. Oh my god. In fact, this is as simplified as I can make this, I think. I might go with this, you know. Let me reread the question. Let me see what's the time. Okay, stats. Time spent doing questions around an hour and 15. Attempted 5. I don't know where to find the solutions for this. I'm gonna look online. Trinity Cambridge. This one's right. This one's right. This one's right. This one's wrong. So far I got 4 out of 5. I mean, considering I haven't attempted the other ones, I'm too tired to do that. Okay, so this is probably it for me. I set out to do this as a marathon, as in like me doing the whole thing until finished. But I'm yes, I am going to. I'm a coward, and I will stop right now because, as J.H. Hardy has said, the limit for a mathematician for creative work is 4 hours, and I'm way past that. Even in the morning when I'm in school and doing very nice maths, I'm still not that bright. So I will take this 4 out of 5 any day. And by the way, the last question wasn't even attempted well. So I I I don't know. Like doing these questions were actually fine. So 3 of them I seen before and got them right. So the questions I didn't see was a probability one and the combinatorics one. Combinatorics is not kind of it used to be one of my worst areas of maths, but by recently I mean since the summer of year 12, where I worked really hard on combinatorics, I kind of managed to be average. And kind of you can probably see by my performance in that question that was okay. That was on the mediocre slash poor side, but before it would have been like very 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 bad. So I suppose that's a positive improvement. On the negative side, I would add that my tendency to make mistakes like the one I did in the very, very easy integration by parts question is reluctantly, I would say, is probably going to be my downfall. But also, my now that I'm reflecting on the fact that I have massively overcomplicated the second question. I didn't overcomplicate the second question. It just felt more natural for me to think about in terms of vectors. And I would argue some people may find that sort of solution much more eloquent than the one I saw in the TSR room. But the TSR room solution, where you just consider 2 angles that each line makes with the x-axis, is perhaps more, you know, what the interviewer might be expecting. But also, I do like what I would like to comment on the fact that the first thing I said is that this kind of very much reminds me of the double angle compound angle formula of tan. So a plus point for me for that, for recognizing that. And if I was an interviewer and that was my observation, instead of going down the vector route, I would assume my interviewer will be like, stop right now. You just said something very important. Think about that. Aside from that, I think I need to revise conditional probabilities. Well, the last time I did them was in my A-level class and further class and revision with TMUA, and they are very nice things to get into interviews. I'm absolutely horrendous at them. So yeah, I mean these are kind of my reflections. I don't know. I'm insanely tired, which I said a jillion times. I don't think I have anything to do except for cry and sleep. So I'm just gonna stop recording. I'm gonna go sleep. Actually, I need to go to the toilet first. So you know what? Bye.